All right, good morning, everyone. So we're going to start off today by reviewing some of the information we learned last week. So we learned about linear versus nonlinear. We've learned about positive versus negative versus no correlation. Let's see, what else did we learn about? We know about bivariate graphs, right? That's aka dealing with two variables. So I want you to take some time and tell me what kind of correlation is this line of best fit that we see as the two variables of interest are the hours spent playing video games versus GPA. So I'm going to give you some time to figure that out. Okay. Press pause if you haven't come up with an answer yet. Okay, so this is going to be a negative. I guess we're not writing today, huh? Ooh, and we're stuck. Let me see. Ah, there it is. Let's fix it. Erase pen. Pen. So this would be a negative correlation, which suggests that as the number of hours playing increases, your GPA decreases, according to this graph. I don't know if this was a peer-reviewed, extra long study with a whole bunch of data, but for this graph, that is the, I guess. Okay, so a special report on the evening news exposes startling fact. When more doctors are on duty at a hospital, more deaths occur. Does this mean that doctors are killing patients? What are some other explanations? So if you're watching this on YouTube, I'd love for you to post it, leave a comment. If you're watching this in class, I'd love for you to chat the answer to me. Do you think that doctors are killing patients? Does that sound like the correct conclusion of this graph? There are a number of answers, but perhaps the most common thread is the size of the hospital. Small hospitals, right, have fewer doctors on duty, and if you have a smaller hospital, it's likely that you're in a smaller town, right? Smaller town would just simply mean less sick people per capita. You know what I mean? Like per the town. So there are fewer deaths. Larger hospitals have, or not per capita, that's what I meant to say. If it was taking into account the population, it's possible that it was the same. But because we're looking at just raw numbers, of course, a smaller town is going to have less people sick than a big hospital. Larger hospitals have more doctors and patients, so there's more of a potential for a patient to die. We could also come up with other things. It could be like maybe if there's more doctors, there's too many hands going on and not enough efficiency. So I don't know. Okay, so vocab for this week, or I guess today's lesson is going to be causation and correlation. So causation is when action A causes outcome B. I drank a soda and now I'm burping. So action A was soda, outcome B was burping because of the carbonation. Correlation is only a relationship. Action A is related to action B, but one event doesn't necessarily cause the other event to happen. So for example, I could say, well, better grades in my class are correlated to me having more students in my class. I'd have to test that out. I have to do experimentation. I can't just say that when I have more students, that means that I'm going to have better grades. So please write this down. How can we determine causation? So I love this image because we see how a sunny day is going to cause an ice cream to melt. We know a sunny day is going to cause a sunburn. And then the correlation would be that sunburns and ice creams melting are related to each other. And yes, they are, but it doesn't mean that if you are getting sunburned that your ice cream is necessarily melting. right? Like you could be sunburned also at the top of a mountain skiing because you're closer in altitude to the sun. Like I think the reason's like there's less filtration. You're just closer. Causation can only be determined from an appropriately designed experiment. In such experiments, similar groups receive different treatments, and the outcomes of each group are studied. We can only conclude that a treatment causes an effect if the groups have noticeably different outcomes. So please write that down as well. How can we determine if variables are correlated? So if there is a correlation between two variables, a pattern can be seen when the variables are plotted on a scatter plot. If this pattern can be approximated by a line, the correlation is linear. Otherwise, the correlation is nonlinear. So we already know about linear and nonlinear. So essentially, correlation occurs when we see a pattern occurring between two variables on a scatter plot. Let's look at an example. Liam collected data on the sales of ice cream cones and air conditioners in his hometown. He found that when ice cream sales were low, air conditioner sales tended to be low, and that is when ice cream sales were high. And that when ice cream sales were high, air conditioner sales tended to be high as well. So ice cream sales low, he saw that air conditioning sales were low. Ice cream sales high, air conditioner sales tended to be high. So Liam can conclude that the sale of ice cream cones and the air conditioner are positively correlated, aka that there is a positive correlation relationship between them. But he can't conclude that selling more ice cream cones causes more air conditioners to be sold. It is likely that the increases in the sale of both ice cream cones and air conditioners are caused by a third factor, an increase in temperature. So I want you all to tell me what your thoughts are on this. Vivek notices that students in his class with larger shoe sizes tend to have higher grade point averages. Based on this observation, what is the best description of the relationship between shoe size and grade point average? Well, as shoe sizes increase, grade point averages increase. When two things are increasing at the same time, we know it's a positive correlation. So if you said positive correlation, you are correct. A principal collected data on all students at her high school and concluded that there is no correlation between the number of absences and grade point average. Which of the following statements are consistent with the principal's finding? A, the number of absences a student has is not a predictor of their grade point average. B, students with fewer absences tend to have higher grade point averages because they are present for more of their academic classes. Or C, there is a linear relationship between the number of absences and grade point average. Give you a moment to think about that. If you said A, the number of absences a student has is not a predictor of their grade point average, you are correct. All right, the scatter plot above, or I should say below, shows the price of a hot dog and small drink at 17 different baseball stadiums. Based on the scatter plot, which of the following statements is true? A, there's a positive linear correlation between the price of hot dogs and soft drinks. B, there's a negative correlation between the price and soft drinks. C, no correlation between the price and soft drinks. Or D, an increase in the price of hot dogs causes an increase in the price of soft drinks. E, the ballpark with the most expensive hot dog has the most expensive soft drink. So 5 choices here. If you said A, there is a positive correlation, you are correct. You could draw a line of best fit, and you would probably see that. it would run something like that, which looks like a positive slope, aka a positive correlation, positive line. Okay, so we're actually going to move into recursion and linear data. So let's talk about what a recursive formula is, because this is just a part of all of this section is relationships and data. So we just looked at causation, correlation, we've seen lines of best fit, like in terms of positive, negative, linear, nonlinear, etc. So now we're talking about recursive formula. So a recursive formula is a formula that defines each term of a sequence using preceding terms. Recursive formulas must always state the initial term or terms of the sequence. So here our recursive formula is going to be a sub n, so that is the value of the third term, fourth term, is going to be equal to that term minus 1. So if it's the fourth term, we're going to be looking at the third term plus the common difference. So let's look at question 1. Cohen decides to take a job with a company that sells magazine subscriptions. He is paid $20 to start selling and then earns $1.50 for each subscription he sells. Fill in the following table showing the amount of money M Cohen earns for selling N subscriptions. Use the process column to note what is happening in each line. So we're going to write a recursive rule for the amount of money Cohen can earn selling magazine subscriptions. So we see that M sub 0 is $20. We see that in step 1, we're going to take M sub 0 plus $1.50. So that's how we get $21.50 because we're adding $1.50. Adding $1.50. And so on and so forth. So if we're going to write a recursive rule for this, right, it's going to be M sub n equals M sub n minus 1 plus the common difference, which is $1.50. You can also write it like this. So if let's say I add 1 to this, I can also add 1 to this and get this. M sub n plus 1 equals M sub n plus $1.50, where M sub 0 is 20. Question 2 in our last question. The rule in question 2 defines a term M sub n plus 1 with respect to the term that precedes it, M sub n. Write a rule that defines a term M sub n with respect to the term that precedes it, M sub n minus 1. How is this rule similar to and different from the rule you wrote in question 2? Let's see. Write a rule. Okay, so actually we ended up, that was the first thing I said, so it's kind of a given. So all I did, and you could look at it backwards, right? So if this was our equation, we could have just done minus 1 and then minus 1. So it would have been M sub n equals M sub n minus 1. Okay, so we're going to stop here. We're going to do a lot more examples. This is just kind of introing you into it. And I will see you all next week. Thanks.